Jai Hind, my name is Mukulit Goel and I am Assistant Professor in Department of MC. Today I am going to present a topic on data stream architecture and Bloom filter from the subject Data Analytics for MC second year students. Paper code is KCA 034. These are the content of my stream. What is streaming data architecture, components of streaming architecture, Bloom filter and its component. First, what is streaming data? Data that flow in a large volume and flow continuously, that is referred as the streaming data. Like we stream any video, live video. So that is the streaming data. In that video, there is a continuous timestamp locking that capture event as they happen, and the examples like the user clicking a link on a web page or recording of the temperature through a sensor. What is its architecture? A data streaming architecture is a framework of software component built to ingest. Ingest means take as an input, process and analyze the data stream, and especially in real time or a near real time scenario. Rather than what is data streaming? Data streaming means rather than reading and writing, we provide a streaming that is continuous, large in space, and may also include some extra components of processing, manipulation or analytics. This is what is our three process. First is ingest. Ingest means from where you are taking an input, like IoT devices through some sensors. We are recording the temperature through some sensors. Transactions, we do any monetary transaction through ATM, through UPI system or anything. Log files are those like we are viewing any video, so the likes or the number of views, all those are like logs and log files. Weather data, that I have already told. Business applications, like I have also explained it earlier, that most of the online companies give special offers on from 6 to 8. Why they give those special offers on 6 to 8, or they mostly advertise their product or offers from between 6 to 8? As they have done analytics and see that when the person is traveling from office to home, they normally serve on mobile or anywhere means in a metro or somewhere. They are during their traveling time, they normally serve about those. So the companies who wants to increase their business, they give the offers especially on that time. That is ingest. What is analyze? Analyze what we have do in real time, like events. So those events, like in current scenario, there are speeches of politicians which are live streaming, and those streaming will be done through some references which is stored in a master database, or might be through a real-time scoring. The real-time scoring means the number of views which their streaming videos is viewed by the people. And third is deliver. Deliver means how it will be informed to you by some alert, by some dashboard messages, or by some or through some storage which is already in the database. What are the component of streaming architecture? First component of streaming architecture is message broker. What is the use of message broker? Basically, message broker is an element that takes the data from the source and it translates into a standard message format for ongoing stream. So what is the process of that? That process is that the component listen and consume the message which is passed by the broker. The first message broker is RabbitMQ, and the tools for this message broking are Apache Kafka and Amazon Kinesis. This is the procedure. Producer will receive the data through Kafka cluster. They divide it into different topics. Like we take an example of Twitter. In Twitter, we see that there are the different topics, and only in those topics the messages or the streaming will be done. Like in politics, we have all the information which is related to the Indian politics or world politics. weather. Like another topic is weather. So in weather, there is a partition on the temperature, on humidity, on pollution. So all this done through a Kafka cluster, and after partitioning, the data will be sent to the consumer. Another component is ETL tools. What ETL? ETL means extract, transform and load. What is purpose? Its purpose is to receiving the query from the user, then transform it into some data or in the form of API for the visualization to the user. The data stream in real time is from one or four or messages brokers. Messages brokers transform and structure the data, and it is analyzed through SQL based analytic tools. Like here are some apps, some services, some sensors and some devices through which message is received, the query is run, and on the message of that query, the actions will be taken, and these actions will be visualized by the user. Third component is serverless query. Serverless query engine. After streaming, how those data will be stored and what are the different approaches through these data will be analyzed. So after streaming data is prepared for consumption by the stream processor, it must be analyzed to provide value, and there are some tools which do this data streaming. The tools for data streaming are Amazon Athena, which is the product of Amazon and the part of the AWS, Amazon Redshift, which is the part of the Amazon Kinesis, Elasticsearch and Cassandra are the example of Kafka, and the purpose of Elasticsearch is a text searching, and the Cassandra is the serving of streaming events to app. Last component is storage. How do we store the data? The data will be stored in two ways, either through a data warehouse or through a message broker. With the data in the data storage, the low cost storage technologies are using by organizations today, and their options are data warehouse or message broker. The advantages or disadvantages of data warehouse or the message brokers are: advantages are easy SQL based analysis can be done in database or data warehouse, but it is difficult to scale. If we use a cloud based storage, then it is expensive also. In the message broker, the data storage is agile. There is no some structure, no some table, we just store the data. But for the retention, it is an issue that how the data can be used. There are some patterns also which are used to remove the duplicacy or used to make our data streaming more secure. The first pattern is idempotent producer. The use of idempotent producer is to protect our data from duplicate events in our input data stream. Every event have the producer, and each producer have its unique ID, and that ID is sent every time when a message sent to a broker. So with the use of this ID, the duplicacy can be removed. Like we see in an example, there is a message processing. In that message processing, there is an array of 11 elements. So in these 11 elements, how the data will be streamed? First step is to consume. Consume means first the input has come. In second step, we do a duplicate check, whether that data is streamed earlier, whether that data is already given an ID. If no, then the third process is executed. If it is a duplicate, then it is rejected at that time only. Third is process that data. Then fourth is we store it with a message ID. So duplicacy can be removed or duplicacy should not happen. Fifth is the commit offset. Commit offset means that message will stored and it can be used or it can be seen by the user. Second is claim check. The implementation of claim checker is done to make sure that streaming data system handles large data sizes. It means the message which is large in large volume, and as we know that in data streaming the message is large and it is continuous process, it is continuously streaming. So claim check is used to manage that large data. The messages from data stream can contain large images, audio and text file. So it is not a ideal situation to send that data directly. So we require some resources and some bandwidth. So the process is, first message with data we receive, then we check it in a data store, and also we do a claim check through an application that how much is the size of that data, how much size it will consume, how much bandwidth is needed. If that data is in the data store, then the application will receive the data and finally we got the output. Third is event splitter. In data streaming architecture, the event splitter pattern is used to split one event into multiple events for streaming analysis. Like the companies want to see what the users are more prone to, what they are mostly seeing in their app. So they will split the events into different portions. They got some order, like I have told, the politics, weather, world news, business news, stock market. So they divide those in order. Give the order, they divide it through split, and after that splitting, different orders will be made. So this provides the granularity in their analysis. Granularity means they will know how many users are watching stock market, how many users are watching politics news, how many users are watching world news. So with this splitting, they can do analytics easily. Fifth is event grouper. After splitting, all the news which is related to politics is grouped into one, and the one special ID is given for that event. Like politics is one event, weather is one event, business is one event, world news one event, sports one event. So the event grouper pattern is used to group similar events in the data streaming architecture that is used for an event that occur numerous times after the few interval. Like in today's, in a month or two, say after 7:30, or normally people watch IPL. So after interval and every 18 hours or 24 hours, the match comes, the streaming is done of that, live streaming is done, and the views will be recorded, logs will be recorded. So that all those things will be done after grouping. Event aggregator. The event aggregator combines related events to produce the new event. What does this mean? This means that when the combine multiple events to calculate the new events average percentile. Like if we talk about sports, there is one sport which is IPL, another sport which is live streaming is cricket match between England and Pakistan. So we group all those cricketing events into one and create an event that is known as cricket. So through that aggregator, the related event will produce a new event, and the logs of that pattern and logs and the patterns of that event will act as the input to event aggregator. How after these components and architecture, now comes the filter, how the filtering is done in data streaming. So the filtering is done through Bloom filters, and these are the probabilistic data structures that saves space and element that belong to a set. Basically these are like the hash tables which are used to keep the track whether the item is hashed to a proper location or not, and check whether the element is most definite not in a database by using one or more hash function and an array of bits. When we check whether the element or event is in the dataset or not in a dataset or any array of bits, then we call it a filter, and it acts as a preliminary test for data entry. What it will do, what is the process of that? Like there is some data, we have an array of 11 elements. What we do, we compute the sequence. We check whether the sequence is in Bloom filter. If it is in a Bloom filter, then we compute that data by using some hash function. Then after applying hash function, that data is searched in the list of array. Whether we find that array, whether we find that element, that event in an array or not. This process is of 3 steps. One is hashing, second is insertion, and third is search a result. If we got a result, then we display it to the user, or if we not got a result, then it will be hashed. It will be inserted using a hash function, and after that, that will be available for the user. These are the 4 types of Bloom filters. One is compressed Bloom filters, spectral Bloom filters, space code Bloom filters, and decaying Bloom filters. How these Bloom filters works? First, we accept the data. For example, my data is text data and which says data MCA. Then we calculate the hash value. The hash value is converted using some algorithm. We find some value using a hash of that text data which is data MCA. Okay, so after that applying some algorithm, we got a value of 1355. So the actual value is computed as per hashing algorithm, which vary in complexity. After calculating the hash value, we try to find out the array length. What is the array length? Array length is to take a mod of the hash value by the length of the array, and mod in programming which is denoted by %. When we perform the mod operation on 2 data MC or 1335, we got an index within the boundaries of the bit array. Like 1355 is divided by 19. So we got the array length of 6. Then we insert the hash into the mod value of array, which is from 0 to 9, and then we search for it. So step 2 and 3 are performed again as the part of the lookup process. An algorithm checks the content of the array as per the mod result. If the value is 0, means the input cannot be conceivably belongs to the set, and if the bit is 1, the input element may be the element of the set. So the operation is allowed only when the output comes as a 0. If the value of bit is come as 1, it means that data that already is in array. The applications of Bloom filters are email availability, recommendation of a new content, cyber security, tracking of IP address, detecting the weak password. All these are applications. So now comes is how to select the hash function. The hash function is selected in 2 ways. One is uniform distribution and another one is independence. In uniform distribution, the hash function is distributed uniformly across the bit array, and it ensures that each bit in an array is equally to the set, therefore minimizing the chances of the collision and minimizing the chances of the false positive. False positive is a condition which we use in the matrix. Second is independence. Independence means multiple hash functions used in a Bloom filter should be independent of each other. We do not consider the hash value of any another event or any another data. Each data is independent of the other data. What it means? It means that the outcome of one hash function is not influenced by the outcome of the another hash function. What are some hash functions used? One is cryptographic hash function, in which we use the algorithm of message digest 5, which I write as MD5. what it will do, it will use especially for the when the uniform distribution is critical. So we use the MD5 algorithm, and these cryptography hashes can be slower. So these cryptographic functions are slower, so they are sometimes they create a bottleneck for some applications. Second is murmur and city hash. It is a non-cryptographic hash function. What is a cryptography? Cryptography basically an encryption process in which the hash function or any process is encrypted into some special text, and that special text is finally have some key, and on the basis of that special text which is encrypted will be decrypted. So this process is known as cryptography. So another is murmur and city hash, which is non-cryptographic hash function, which is designed to be fast and produce the uniform distribution of the hash values. What is function? The functions of the Bloom filter is to insert an element into a set, and second is query whether an element is in the set or not in a set. Last application which I have already discussed earlier. Thank you.